Hello and welcome to my walkthrough of the Pearson Edexcel AS level exam for May 2023, Pure Mathematics, Paper 1. Let's jump straight into it. So a curve has equation y equals 2/3 x cubed minus 7 over 2 x squared minus 4x plus 5. And what we need to do for part A is we need to differentiate. So we need to find dy dx. In order to do this, we're going to consider each term individually. So the differential of 2/3 of x cubed, I will just leave the 2/3 here, and then we'll differentiate x cubed. We'll take the power in front, keep the x there, and we'll reduce the power by 1, giving us 3x squared. We'll do the same for the next term, 7 over 2 outside the brackets, and then we'll differentiate x squared. So take the power in front, and we'll reduce the power by 1, just leaving the x on its own. Do the same for the next one, take the 4 out the front. So we just have x for this one, so we're going to reduce the power of x, and that will be x to the 0, which is equivalent to just 1. And then when you differentiate the 5, that will just give us 0. We'll simplify this. 2/3 multiplied by 3x squared is just 2x squared, minus 7 over 2 multiplied by 2x is just 7x, and minus 4 times 1 is just minus 4. And that is our answer to part A. Then part B. Hence, find the range of values of x for which y is decreasing. In order to find this, what we're going to need to do is differentiate, which we've already done, make it equal 0, solve the equation you're left with, and then those solutions, you have to take the range of values between these solutions where y is less than 0. So I normally do this by drawing the graph at the end, which I'll do this time. So we already have the differential, which is 2x squared minus 7x minus 4, make it equal 0. Now we need to factorize this into brackets. So we have a 2x squared at the front, which means the brackets are going to be 2x plus something, and then x plus something, as we need the x terms to multiply together to get the 2x squared. Since we have a minus 4 at the end here, we know that the numerical values that are inside these brackets are going to need to multiply together to get minus 4. Only way you can do that is 1 times minus 4 or minus 1 times 4, and 2 times minus 2. But if we look at the middle, we know that we need to get to minus 7x, so we basically are going to need the number that's in here multiplied by the 2x, plus the number that's in here multiplied by the x needs to get us to minus 7. Now, going back to these over here, I can see that we're going to end up with, in order to make the minus 7, minus 4 and 1. Because if you try and do minus 2 times 2x, you're just going to get minus 4x, and then 2 times the x is going to give you 2x. You're not going to end up at 7. So we need a mixture of an odd and an even number. So if I am looking at the minus 4 and the 1, if I was to put the minus 4 here, we would then end up with minus 4x, and then the 1 would be here, which would give us 1 times 2x, positive 2x. We're going to end up with minus 2x, which means the 4 needs to multiply by the 2. So it's going to be in the right-hand bracket, and we know that it's minus 7, which means we need minus 8 and positive 1x. So this is going to be minus 4, and this is going to be positive 1. And just to check it, that's going to be 2x multiplied by x is 2x squared, plus 1 multiplied by x just gives us x. Then the 2x multiplied by the minus 4 gives minus 8x, and then the 1 multiplied by the minus 4 gives you minus 4. Simplifying this takes us back to where we wanted to be. So these are our correct brackets. So that means 2x plus 1 equals 0, or x minus 4 equals 0 for our two solutions. This leads us to x equals minus a half, or x equals 4. Now, like I said earlier, we need to find the correct range of values between these two solutions for which y equals 0 in our function. So if I draw the graph of our differentiated function, we know that it crosses the axis at x equals 4 and x equals minus a half. We know it's an x squared graph, so it will have this shape. And we're looking for all the set of values where y is less than 0, which is the values below the axis, which is going to be all of these. which are the values -1/2 and 4. And that's our final answer. So question number 2 here. Using the substitution u equals square root of x or otherwise, solve 6x plus 7 root x minus 20 equals 0. So what I'm going to do is I'm going to substitute. So I'm going to say u equals root x, therefore u squared equals x. So we can rewrite this as 6u squared plus 7u minus 20 equals 0. Then I'm going to say use quadratic formula to find the solutions to this equation. So minus b, which is minus 7, plus minus the square root of b squared, which is 49, minus 4 times a, which is 6, times c, which is minus 20, all over 2a, which is 12. That is minus 7 plus minus the square root of 6 times 20 is 120, times 4 is 480. We've got two minuses in there, so they make a plus, which makes this the square root of 529, all over 12. On my calculator, the square root of 529 is just 23. So I'm going to say this is minus 7 plus minus 23 over 12, which is going to give us minus 30 over 12, or 16 over 12. So we're going to say, therefore, u equals, we'll simplify this down to minus 5 over 2, or 4 over 3. Now, we're told in the question we're using the substitution u equals the positive root of x. So what I'm going to do is discount this one and just leave us with 4 over 3. Therefore, x is just u squared, is just 16 over 9, and that is our answer. Here we have question number 3. Figure 1 is a sketch showing the position of 3 phone masts, A, B and C. The masts are identical and their bases are assumed to lie in the same horizontal plane. From mast C, mast A is 8.2 kilometers away on a bearing of 72 degrees. So what I'm going to do first is draw a line between C and A. Should be a straight line. That's 8.2 kilometers. And we know that this bearing here is 72 degrees. Mast B is 15.6 kilometers away on a bearing of 39 degrees. So similarly, I'm going to draw another line there. This is 15.6 kilometers. And I'll just extend this line up here to make it a bit easier. And this bearing here is 39 degrees. Find the distance between masts A and B, given your answer in kilometers to one decimal place. So we want this dotted line here, which I'm going to call x. So the way we're going to work this out is by using the cosine rule. So I'm just going to say cosine rule, which is just the side length x squared equals 8.2 squared plus 15.6 squared minus 2bc cos x, which is going to be 2 times 8.2 times 15.6 cos, and then the angle, which is going to be this angle here, which is y, but we know that it's 72 degrees from bearing from C to A, and it's 39 from C to B, which means angle y is just going to be 72 minus 39 degrees, which is 33 degrees, which you can see by the way I've drawn the diagram with the arrows, so cos 33. So what I'm going to do here is I'm going to type this into my calculator. So 8.2 squared, first of all, is going to be 67.24. 15.6 squared is going to be 243.36 minus 2 times 8.2 times 15.6 multiplied by cos 33, which is going to be 214.57. Add all these together. 67.24 plus 243.36 minus 214.57 and we're going to get 96.03. Therefore, x equals the square root of this, which is 9.8 kilometres. And then part B, an engineer needs to travel from mast A to mast B. Give a reason why the answer to part A is unlikely to be an accurate value for the distance the engineer travels. What they're looking for here is some sort of real-world answer. So it's an engineer travelling from a mast to another mast, so the road may have obstacles. You could also say the road might not be straight. You could say that he might have to take a detour. You might say that it might be up a hill. Like, we're just looking, the way we have the question word is this is a straight line. So it's pretty unlikely that in the real world you're just going to walk a straight line from one mast to another. And that's all we need for question 3. Question number 4, part A. Sketch the curve with equation y equals k over x, where x does not equal to 0, and where k is a positive constant. So what we're going to do is just draw out our axis just here. So y-axis and x-axis. Since we are drawing a graph of k over x, we don't need to add labels in terms of figures onto the axis here. So x is never equal to 0, and a 1 over x graph looks like this, where we're getting closer and closer to the axis, but we just need to make sure you're absolutely never touching it. A bit like this. Ooh. You need to have a positive and a negative side of it, because it doesn't specify if x is greater than 0, less than 0, and that's all we need to do for part A. And then part B, hence or otherwise, solve 16 over x is less than or equal to 2. So I'm going to look at this as two separate graphs. So if we consider just this one down here, this is for values of x less than 0. So I'll put when x is less than 0, 16 over x is less than 2, because any value of x that you put in, any value of x will be negative. Therefore, 16 over x is going to be less than 0 as well. So, solution, therefore, is x is less than 0. Being careful not to use x is less than or equal to 0, as we know x is not equal to 0. And now if we look at this quadrant, this is for the positive x, so we'll say when x is greater than 0. What we'll do now is we'll say 16 over x is less than or equal to 2. So if we multiply both sides by x, we're going to have 16 is less than or equal to 2x. Dividing through by 2, we have 8 is less than or equal to x. Therefore, x is greater than or equal to 8 is the other solution. And that's all we have to do, so we are done. So question number 5. The finite region R, shown shaded in figure 2, is bounded by the curve with equation y equals 4x squared plus 3, the y-axis, and the line with equation y equals 23. Show that the exact area of R is k root 5, where k is a rational constant to be found. So the way we're going to do this is we are going to work out what the area of this section is here, the full rectangle. Then we're going to work out the area of under the curve by integration, and then we will do the rectangle's area minus the area under the curve, and that will leave us with R. So in order to find the area of the rectangle, area of full rectangle, we need the x-bound when y equals 23. So if we say 4x squared plus 3 equals 23, we can work out the value of x for which is on this point here. So that's going to be 4x squared equals 20, which means x squared equals 5. which means x equals root 5, and it's the positive root 5 as we're in the positive x quadrant. So, therefore, area of a rectangle is going to be nice and easy. 23 multiplied by root 5. 23 root 5. So next we will integrate function to find area under curve. And we're going to integrate this in the bounds root 5 to 0. So integrate between root 5 and 0. So we're going to integrate 4x cubed plus 3, and that's just going to give us raise the power divided by the new power. So 4/3 x cubed plus 3x. We would have a plus c, but we are integrating under bounds, so they would just cancel out. This is going to be between root 5 and 0. If we put these numbers in, so root 5 cubed is just going to be 5 root 5, so we're going to get 4/3 of 5 root 5 plus 3 root 5. Now, you would then do the lower bound, but for this it's 0, and when 0 goes into the x cubed term and the x term, we get nothing, so we don't need to worry about that. So this will simplify to 20 root 5 over 3 plus 3 root 5, and that is the area of shaded region. Therefore, R is going to be the rectangle minus shaded. So the area of the rectangle is 23 root 5 from earlier, and the area of the shaded region is 20 root 5 over 3 plus 3 root 5. I'm going to put it all over 3 to make it a little bit easier for me, and that's just going to be 69 root 5 over 3 minus 20 root 5 over 3 minus 9 root 5 over 3. Simplifying out gives us 40 over 3 root 5, and that is in the format that the question asked for it. So we are done. That is our answer. Question number 6. The circle C has equation x squared plus y squared minus 6x plus 10y plus k equals 0, where k is a constant. Part A, find the coordinates of the centre of C. So we know that an equation of a circle is x minus a squared plus y minus b squared equals r squared, where a, b is the centre of the circle. And we are told that this equation here is the equation of a circle. So it must be in this format. First thing I'm going to do is move the r squared onto the other side, because we can see it equals 0 over here. So this is going to be x minus a squared plus y minus b squared minus r squared equals 0. Now if I expand out these brackets, we're going to get x squared minus 2ax plus a squared plus y squared minus 2by plus b squared minus r squared equals 0. So I'll rewrite this now to make it match up against the format at the top. So we're going to have x squared plus y squared minus 2ax minus 2by plus, and I'll put this in brackets, a squared plus b squared minus r squared equals 0. And that in the brackets represents k. So we can then see that we've got minus 6 lots of x here, and we've got minus 2ax here, so minus 6 equals minus 2a, and similarly we've got 10y here, and minus 2by down the bottom. So a equals 3, b equals minus 5, therefore the centre of the circle is 3 minus 5. Given that C does not cut or touch the x-axis, find the range of possible values for k. Well, I've already said k is a squared plus b squared minus r squared, so I'll do this. A squared plus b squared minus r squared equals k. So we know a is 3, so that's 9. We know b is minus 5, so that's 25. Minus r squared equals k. So 34 minus r squared equals k. R is greater than 0, as radius of a circle is greater than 0. Therefore, k must be less than 34. As you put 0 into here, you're going to get k equals 34, but as soon as you increase r, k is going to become less than 34 because we're subtracting the radius squared away. So that's one bound, and therefore the other bound, we know that c does not cut or touch the x-axis, which means the y value never reaches 0. I will put as circle doesn't touch x-axis, y value never 0. Therefore, biggest radius can be is 5, because we have minus 5 over here as the center of the circle. It can never touch the x-axis. So if the biggest the radius can be is 5, therefore 34 minus 25, which is 5 squared, equals k. So k equals 9 is the other bound, but does not touch. So k must be greater than 9. So I'll just pop it up here. 34 k 9 is our answer. Question number 7. The distance a particular car can travel in a journey, starting with a full tank of fuel, was investigated. From a full tank of fuel, 40 litres remained in the car's fuel tank after the car had travelled 80 kilometres. From a full tank of fuel, 25 litres remained in the car's fuel tank after the car had travelled 200 kilometres. Using a linear model, with V litres being the volume of fuel remaining in the car's fuel tank and D kilometres being the distance the car had travelled. Part A, find an equation linking V with D. Well, firstly, there is going to be a constant which needs to represent the value of a full fuel tank. So if D is 0, we need to have an amount. So what we're going to say is this has to be of the format of V being the volume, the litres of volume of the fuel, equals something, which we'll say A, multiplied by D, which is the distance, add this constant, which we'll call B, which is a full tank of fuel. So for the first point, we have 40 litres remaining in the car's fuel tank. So that's going to be 40 equals A multiplied by 80 plus B. And we also have, for the other line, 25 equals 200 multiplied by A plus B. We'll call this equation 1 and this equation 2. I'm going to do 2 minus 1. So what I'm going to get is 25 minus 40 is minus 15 equals 200A minus 80A gives 120A. B minus B gives you nothing. Therefore, A is going to be equal to minus 1/8. So what I'm going to do is put back into equation 1. Therefore, we have 40 equals minus 1/8 times 80 plus B. So 40 equals minus 10 plus B. Therefore, B equals 50, which would be a full tank of fuel. So our equation is V equals minus 1/8 times D plus 50. Given that on a particular journey, the fuel tank of the car was initially full and the car continued until it ran out of fuel, find, according to the model, part BI, the initial volume of fuel that was in the fuel tank of the car. Well, we've already worked that one out. I'm just going to write that straight down. That's going to be 50 litres. As if you put 0 into here, you're going to get V equals 50. And D being 0 would be no distance travelled. And part II, the distance that the car travelled on this journey. So we need to find when v becomes 0 then. So if I rewrite our equation as 0 equals minus 1/8 d plus 50, bring the 50 onto the other side, we'll say minus 50 equals minus 1/8 d, times both sides by minus 8, we're going to get d equals 400 kilometres, and that will be the total distance that it's travelled. In fact, the car travelled 320 kilometres on this journey. Part C, evaluate the model in light of this information. Well, all we need to say here is model isn't good, as 320 kilometres is significantly less than the 400 kilometres that it should have travelled. And that is us done. Question number 8. Figure 3 shows a sketch of a curve C and a straight line L. Given that C has equation y equals f of x, where f of x is a quadratic expression in x, C cuts the x-axis at 0 and 6, L cuts the y-axis at 60 and intersects C at the point 1080, use inequalities to define the region R, shown shaded in figure 3. What we're going to need to do here, we're going to need to find the equation of this line, L, and the equation of this curve, C, and we're going to need to state all the values that fall in that region R using inequalities. So let's start by working out f of x. So we know it's a quadratic expression. We know that the roots are 0 and 6. So when f of x equals 0, x equals 0, or x equals 6. So f of x is going to then equal x minus 0, lots of x minus 6, and multiplied by a constant at the front. We don't know what that constant is just yet, as this represents the two solutions of the quadratic equation. So I'll just rewrite this as ax lots of x minus 6. 1080 lies on C, therefore 80 equals 10 lots of a multiplied by 10 minus 6. So all I've done there is I've put these 2 points, this 1 point, into our equation. So that's the y element is 80, the x element is 10. So this is just going to be 80 equals 10a multiplied by 4, so 40a. A therefore equals 2. Therefore, f of x equals 2x lots of x minus 6. Then for the line L, we're going to use the formula y equals mx plus c to work this out. We know it crosses the y-axis at the point 60. So intercept is 60, therefore c equals 60. And we have that 1080 is also on this line. So if we do the same thing here, where we put 80 equals 10 lots of m plus 60, take 60 off both sides, we get 20 equals 10m, so m equals 2. Just scroll down. So our equation of our line is y equals 2x plus 60. Let's split these two. So we know, if I scroll back up again, we know that the region R is for all values less than on this line here, L, and it's capturing all the values that are in the curve but are less than that line, which means our inequality is going to be y is less than or equal to that straight line, which we said is 2x plus 60, but it is greater than or equal to everything on f of x, which is 2x lots of x minus 6, and that is our answer. Question number 9. Using the laws of logarithms, solve the equation 2 log base 5 of 3x minus 2 minus log base 5 of x equals 2. So what we're going to do here is we're going to use the power rule of logarithms first and foremost by changing that first term into log base 5 3x minus 2 squared by moving the number that was at the front of the logarithm to the power. Next, we're going to use the quotient rule, which basically means you can combine two terms that are at the same logarithm base, and then they become divided by each other if they are minus, or they become multiplied by each other if they are positive. So this becomes log base 5 of 3x minus 2 squared over x, just like that. I'm now going to apply the rule of if you do 5 to the power log base 5 of x, this is just equivalent to x. So I'm going to use that in here and say 5 to the power log 5 of everything in this bracket squared over x equals 5 to the power 2. So all I'm doing there is taking 5 to the power of both sides. And then, like I've said over here, these two are going to cancel out, and that will just leave us with 3x minus 2 squared over x equals 5 squared, which is just 25. Multiply through by x, and we get 3x minus 2 squared equals 25x. Expand out the brackets, and we get 9x squared minus 12x plus 4 equals 25x. Take the 25x onto the other side, we get 9x squared minus 37x plus 4 equals 0. We can factorize this, so this is going to be 9x on one side, and then we need just an x here to make the 9x squared up. To get to 37, we're going to need to do the 9x multiplied by minus 4 to get to minus 36x, and then minus 1 here to get the minus 37x, which means our solutions are x equals 1 over 9 and x equals 4. But what we just need to check, back at the very start here, we are doing log base 5 of 3x minus 2. So log 5 3x minus 2. So for these solutions, if we do it for this one, we're going to get 3 lots of 4 is 12, minus 2 is 10, that's fine. But if we do it for this one, we're going to get 3 over 9 minus 2, which is a negative number. Cannot take log of negative number, which means this is not a solution. Therefore, x equals 4 is the only solution here. Question number 10. The line L1 has equation y equals 3 over 5x plus 6. The line L2 is perpendicular to L1 and passes through the point B80 as shown in the sketch in figure 4. Part A, show that an equation for the line L2 is 5x plus 3y equals 40. So, we know it's perpendicular to y equals 3/5 x plus 6. Therefore, the gradient is going to be minus 5/3 x, as it's the reciprocal negative for perpendicular lines. Therefore, the equation of line 2 is y equals minus 5/3 x plus c. We know that it goes through the point 80. So 80, y is going to be 0. We're going to have minus 5 times 8 over 3 plus c. So 0 equals minus 40 over 3 plus c. Therefore, c equals 40 over 3. Therefore, L2 is y equals minus 5 over 3x plus 40 over 3. If we times it all through by 3, we get 3y equals minus 5x plus 40, or 5x plus 3y equals 40, as required. Now, given that lines L1 and L2 intersect at the point C, line L1 crosses the axis at the point A, find the exact area of triangle ABC, giving your answer as a fully simplified fraction in the form P over Q. So, well, we have point B already. So B is 0.80, which we know. To find A, we need to put y equals 0 into our equation that we started with, which was y equals 3/5 x plus 6. Therefore, 3/5 x equals minus 6. Times both sides by 5, we get 3x equals minus 30. X equals minus 10. Therefore, A is the point minus 10, 0. And then for point C, this is going to be where the two lines cross. So this is going to be where two lines cross. So when x and y are on both lines. So what I'm going to do is make them equal each other. So we have y equals 3/5 x plus 6. And we have y equals minus 5/3 x plus 40 over 3 from earlier. Therefore, we're going to do 3/5 x plus 6 equals minus 5/3 x plus 40 over 3. So we're making them equal each other so we can work out x. I'm going to times everything through by 15 just to completely clear out the denominators here. So that's going to be 9x plus 90 minus 25x plus 200. That's going to be then 34x equals 110. Therefore, 17x equals 55. So x equals 55 over 17. Just going to scroll down. So if x equals 55 over 17, we're going to have y equals 3/5 lots of 55 over 17 plus 6. So that on my calculator, 55 over 17 times 3 over 5 gives us 33 over 17 plus 6, which just gives us 135 over 17. So C is the point 55 over 17, 135 over 17. So the area of the triangle is now going to be a half base times height, as it's a right angled triangle because the lines are perpendicular between L1 and L2. Go back to our picture. The base is going to be the distance between point A and point B, which we know is 18 because we know this is minus 10 and this is 8. And our height is just going to be from 0 up to the y value for C, which we've already worked out as 135 over 17. So this is going to be a half times 18 times 135 over 17, which is just 1215 over 17. And that is the form that they want it in a fully simplified fraction in the form P over Q. 17 is prime, and we cannot simplify any further than that. Question number 11. The height h meters of a plant t years after it was first measured is modelled by the equation h equals 2.3 minus 1.7 e to the minus 0.2 t. T is real and t is greater than or equal to 0. Using the model, find the height of the plant when it was first measured. So all we need to do here is take t equal to 0, as that will be the initial point when it was first measured. No time has passed, so this is going to be h equals 2.3 minus 1.7 e to the power 0. And as we know, anything to the power 0 is just 1. Therefore, we have 2.3 minus 1.7, which is 0.6 meters initial height of the plant. Part B. Show that exactly 4 years after it was first measured, the plant was growing at approximately 15.3 centimetres per year. So in order to find the rate, we're going to need to differentiate. So dh dt. 2.3 differentiated just gives you 0, as there's no t terms there. Then we will do minus. So to differentiate the exponential function, what we need to do is multiply the term by the power that the e is going to. So We're going to multiply it first by the minus 0.2, and then we still have 1.7 lots of it, and then we do not change the power that the exponential function is attached to. So we'll simplify this, will become minus minus becomes a positive, so we get 0.34 e to the power minus 0.2t, and we are told what we want at t equals 4, because it's exactly 4 years after it was first measured. Therefore, we get 0.34 e to the minus 0.8, and we can just do this on our calculator. So e to the minus 0.8 multiplied by 0.34, I get 0.15277 meters, which is approximately 15.3 centimeters as required. And part C. According to the model, there is a limit to the height to which this plant can grow. Deduce the value of this limit. The limit is just 2.3 meters. This is because if t is as big as it could possibly go, so let's say as t tends to infinity, we will have e to the power of minus infinity, and e to the power minus infinity would just tend towards 0. So e to the power minus infinity tends towards 0. Therefore, h tends towards 2.3, as this bit here would just be 0. And that's the question done. Question number 12. Show that the equation 4 tan x equals 5 cos x can be written as 5 sine squared x plus 4 sine x minus 5 equals 0. So this is part A. So I'm going to start by writing 4 tan x as 4 sine x over cos x. So let's rewrite this as 4 sine x over cos x equals 5 cos x. Now we'll multiply everything through by cos x, and that will give us 4 sine x, as the cos x will cancel out, and 5 cos squared x. We know that cos squared x equals 1 minus sine squared x, as cos squared x plus sine squared x equals 1. Therefore, this is the same as saying 4 sine x equals 5 lots of 1 minus sine squared x. Therefore, this is 4 sine x equals 5 minus 5 sine squared x, which we can rewrite as 5 sine squared x plus 4 sine x minus 5 equals 0, as required. Part B. Hence solve for 0x is between 0 and 360 degrees, 4 tan x equals 5 cos x, giving your answers to one decimal place. So all we need to do here then is solve this equation. 4 sine squared x plus 4 sine x minus 5 equals 0, which I will use the quadratic formula for, so minus b plus minus the square root of b squared minus 4ac all over 2a, which is going to be minus 4 plus minus the square root of 116 over 10, which will be the equivalent of sine x, as sine x is our term that we are squaring and finding the solution for. So on my calculator, if I do minus 4 plus the square root of 116 divided by 10, I get sine x equals 0.67703, and if I do minus 4 minus square root of 116 divided by 10, I get minus 1.47703. So since sine x cannot be a negative, this cannot be a solution. So if we use the other one and we do sine to the minus 1 of 0.67703, we get 42.6 degrees. And due to the nature of the sine graph, we know that this will also be a solution where 180 minus 42.6 degrees gives an answer, So that is going to be 137.4, and these are our two solutions to one decimal place. Part C. Hence find the number of solutions of the equation 4 tan 3x equals 5 cos 3x in the interval between 0 and 1800 degrees, explaining briefly the reason for your answer. So what I'm going to say is we have two solutions to, what was it, 4 tan x equals, was it 5 cos x? 5 cos x. When x is between 0 and 360 degrees. Therefore, it's going to be 10 solutions for 4 tan x equals 5 cos x for 0 and 1800 degrees. Therefore, we're going to have 3 times 4 tan 3x equals 5 cos 3x for 0 between x between 0 and 1800 degrees. Therefore, 30 total solutions. Question number 13. Relative to a fixed origin O, point A has position vector 10i minus 3j, point B has position vector minus 8i plus 9j, point C has position vector minus 2i plus pj, where p is a constant. Part A, find AB. So in order to find AB, all we need to do is OB minus OA. Therefore, OB is just the position vector, which is minus 8i plus 9j minus 10i minus 3j, which is just, if you separate the I and the j components, is going to be part B. Find the size of AB, giving your answer as a fully simplified surd. So in order to find this, we need to do the square root of 18 squared plus 12 squared. So on my calculator is 18 squared plus 12 squared is 468, so it's the square root of 468. They want this as a fully simplified surd, so my calculator immediately does that, but if it didn't, you would find out a square number that is a factor of 468, which in this case would be 36, so the square root of 36 is 6, which is why we have 6 root 13 as our answer. Given that points A, B, and C lie on a straight line, part CI, find the value of P. So the way I would do this is I would consider the gradient. As all three of these points are on a straight line, let's just say A, B, C, the gradient is going to be the same if I looked at AB or if I looked at AC. So I'm going to look at what we would normally do as dy dx to work out your gradient. It's going to be dj di for the purposes of this. So dj di for AB, we've already worked it out earlier, so let's just put it into this. So we're going to have difference in j is 12, difference in I is minus 18, so this is just minus 2/3. Therefore, the gradient, the dj di at AC, is going to be minus 2/3. But if I put in the difference in j, so that is going to be minus 3 minus p, and the difference in I, which is going to be 10 minus minus 2, which is 12. Take the minus outside and I get minus p plus 3 over 12 equals minus 2/3. So that means p plus 3 over 12 equals 2/3. Therefore, multiplying up, we get 3p plus 9 equals 24. So 3p equals 15. Therefore, p equals 5. And part II, state the ratio of the area of the triangle AOC to the area of the triangle AOB. We've inadvertently done that because I identified this 2/3 here. So since the ratio of AC to AB as a line is 2:3, the ratio of the triangle is also 2:3. And that's the end of the question. Question 14. Find in simplest form the coefficient of x to the power 5 in the expansion of 5 plus 8x squared, lots of 3 minus a half x to the power 6. So this is going to be a binomial series question, and we're going to need to expand out this right-hand side into a binomial series format. But before we do that, we'll just consider these bits on the left-hand side. The 5 is going to multiply by the right-hand side, and that is going to be attached to an x to the 5 term, so that we can get which part of x to the 5 is that, which sounds quite simple. But then for the 8x squared bit, you're going to multiply that by an x cubed term, so that together they make up the x5. So we're going to have to find the x to the 5 term in the binomial expansion and the x to the 3 term, and then add them both together at the end. So the binomial series follows the below formula. I'm just going to write it out. So a to the n plus n choose 1, a n minus 1, b, and then we have n choose r, a n minus r, b to the r, plus b to the n. So we'll start by looking at the x5 coefficient. So for us, we have a equals 3, b equals minus a half x, n equals 6, and r equals 5 for this one. So we're going to look at our term here. We're going to have 6 choose 5, which we're looking at this here. So n choose r is 6 choose 5. A to the power of n minus r is 3 to the power of 6 minus 5, which is 3 to the power 1. B, which is minus a half x, to the power 5. So 6 choose 5 is just 6. 3 to the power 1 is just 3. Minus a half to the power 5. Minus a half squared is a quarter. Cubed is an eighth. To the power 4 is to 1 over 16. So 2 to the power 5 is over 32. So we're going to have minus 1 over 32. X to the 5. Simplified down, 18 out of 32, x to the 5, or minus 9 over 16. We'll hold that there for a minute. Then we'll consider the x cubed coefficient of the binomial. So now we still have a equals 3, b equals minus a half x, n still equals 6, r now equals 3. So we're going to now do 6 choose 3. Then we have 3 to the power 3. We have minus a half x to the power 3. 6 choose 3 on my calculator is just 20. 3 cubed is 27. And then minus a half cubed is minus an eighth x cubed. Simplifying this out, we get minus 540 over 8x cubed. And that will simplify down to minus 135 over 2x cubed. So, like I said earlier, we now need to basically do 5 multiplied by the x5 term, which is minus 9 over 16, which gives us minus 45 over 16. And we need to do 8x squared multiplied by the minus 135 over 2x cubed term. On my calculator, I'll just do that. So that comes out as, that's 540 again. Could have guessed that. X to the power 5, and that is still a minus. And that's also x to the power 5. Now we just need to add them together. So minus 540 minus 45 over 16 minus 8685 over 16 x to the power 5. Question 15. The curve C1 has equation y equals 8 minus 10x plus 6x squared minus x cubed. The curve C2 has equation y equals x squared minus 12x plus 14. Part A, verify that when x equals 1, the curves C1 and C2 intersect. So, they intersect if the x and y values are the same. So, x equals 1, I'm going to put that into curve C1, and I get y equals 8 minus 10 plus 6 minus 1, which is going to be 8 minus 10 is minus 2, plus 6 is 4, minus 1 is 3. And for curve C2, we're going to have x equals 1, x squared is going to be 1 minus 12 plus 14. This is 3. As x, y values are the same, they intersect at 1, 3. The curves also intersect when x equals k. Given that k is less than 0, use algebra to find the exact value of k. So what we're going to need to do here is we're going to have to make the two equations equal each other. So we're going to say 8 minus 10x plus 6x squared minus x cubed equals x squared minus 12x plus 14. And the reason we're getting them to equal each other is that we need to know that the y value is the same. So if the y value is the same, then the y here is going to equal the y here. Then we can cancel out the x's and solve for the x's, and we'll get x equals. So I'm going to rearrange this so that I get positive x cubed term. So I've added that to that side. Then I've got 1x squared on the right and 6x squared on the left. So we're going to now have minus 5x squared on the right, minus 12x on the right, minus 10x on the left. So we're going to add the 10x to the other side. We get minus 2x. Positive 14 minus the 8 is a positive 6 equals 0. And we now have to solve this equation. So what we know is that x equals 1 is a solution, because we already know that the curves intersect when x equals 1. Therefore, x minus 1 can be taken out of our equation. So if x minus 1 can be taken out of our equation, we can rewrite our equation as x minus 1 lots of an amount of x squared plus an amount of x plus a constant. So if I expand out this right-hand side now, we're going to have ax cubed minus ax squared. So that's just multiplying this x minus 1 by this ax squared. Now I'll multiply it by the bx, so plus bx squared minus bx plus cx minus c. And again, we know this equals x cubed minus 5x squared minus 2x plus 6. I will now compare the terms on the left-hand side with the right-hand side. So for x cubed terms, we have that a must equal 1, because that's the only x cubed term on the left-hand side and the right-hand side. For x squared, we know that minus a plus b must equal minus 5. We already know that a is 1, so minus 1 plus b equals minus 5, so b equals minus 4. For our x terms, we have minus b plus c equals minus 2. We already know that b is minus 4, so minus 4 is positive 4, plus c equals minus 2, so c must equal minus 6. And the constant terms will tell us that minus c equals 6, which confirms that c is minus 6. Therefore, we can rewrite this. I'm just going to scroll down a bit. So we can now say x cubed minus 5x squared minus 2x plus 6 equals x minus 1 lots of ax squared, where a is 1, so x squared, minus 4x minus 6. Now we just have to solve this equals 0 to get the two remaining roots. So we'll solve this using the quadratic formula. So minus b is going to be positive 4 plus minus the square root of b squared minus 4ac is going to be minus 4 times minus 6. So minus 4 times minus 6 times 1 all over 2a, which is just 2 in this scenario, gives us 4 plus minus the square root of 40 over 2. Square root of 40 is the same as the square root of 4 times the square root of 10. So if I rewrite that, I get 4 plus minus the square root of 4 is 2 root 10 over 2, which is 2 plus minus the square root of 10. We know that k is less than 0 from the question. Therefore, k equals 2 minus the square root of 10. Question 16. A curve has equation y equals f of x, where x is greater than or equal to 0. Given that f dash of x equals 4x plus a root x plus b, where a and b are constants, the curve has a stationary point at 4, 3. The curve meets the y-axis at minus 5. Find f of x, giving your answer in its simplest form. What I'm going to say first is if stationary point, then we have f dash of x equals 0 by definition of a stationary point. And we know that stationary point is at 4, 3. Therefore, f dash of 4 equals 0. So we would have 4 lots of 4. All I'm doing here is I'm putting 4 into f dash of x, plus a square root of 4 plus b equals 0. Therefore, we have 16 plus 2a plus b equals 0. And we will park that for the time being. Now, we obviously need to find f of x, so we're going to need to integrate f dash of x. So I'm going to say integrate f dash of x. Therefore, f of x equals, first thing I'm going to do is just rewrite f dash of x here as 4x plus ax to the half plus b. So all I've done there is change the square root to ax to the half. I find that easier when there's a square root to integrate, when I've got the actual physical indice on there. So we're integrating 4x, which is going to be raise the power and divide by the new power, so 2x squared. Raise the power, so x to the 3 over 2, divide by the new power, so we're going to get 2/3 of ax to the 3 over 2. Then we're going to have plus bx. Then we're going to have a constant c. We know that the curve meets the y-axis at minus 5. So I can say when x equals 0, which will be when the curve meets the y-axis, y equals minus 5. Therefore, f of 0 equals 0 plus 0 plus 0 plus c, and that's going to equal minus 5. Therefore, c equals minus 5. So next step, we know that when x equals 4, y equals 3. Because we are told that point on the line, on the curve. So if we say f of 4, we have 2 times x squared, which is going to be 2 times 16, so 32, plus 2/3 lots of a times x to the 3 over 2. So that's going to be 4 cubed square rooted, which is just 8, because 4 cubed is 64. Square rooted is going to be 8, plus 4b minus 5. And we know that equals 3. So I'll just tidy this up a bit. We're going to have 32 plus 16 over 3a plus 4b equals 8. I'll take the 32 onto the other side as well, so I get 16 over 3a plus 4b equals minus 24. I now have simultaneous equations, so we have equation 1 up here and equation 2 down here. So what I'm going to do is I'm going to rearrange equation 1 to say b equals minus 16 minus 2a. Therefore, let's put it into 2. So we have 16 over 3a plus 4 lots of minus 16 minus 2a equals minus 24. We'll just scroll down here. So we're going to have 16 over 3a minus 64 minus 8a equals minus 24. Times everything by 3. 16a minus 192 minus 24a equals minus 72. Add 192 to both sides. We're going to get minus 8a equals 120. A equals minus 120 over 8. which is 60 over 4, which is minus 15. Therefore, b equals minus 16 plus 30. b equals 14. All I've done there is put it back into this equation 1 here. So, we know a, we know b, we know c. Therefore, f of x equals, I'll just scroll up a little bit, f of x equals 2x squared plus 2/3 of 15, which is going to be 10, but it's a minus, so we're going to have minus 10x to the 3 over 2 plus 14x minus 5, and that is our final answer. Question 17. In this question, p and q are positive integers with q greater than p. Statement 1. Q cubed minus p cubed is never a multiple of 5. Part A, show by means of a counterexample that statement 1 is not true. So what we're going to do here, let q equal 6, let p equal 1. 6 cubed, so q cubed minus p cubed is therefore 6 cubed minus 1 cubed. And 6 cubed is 216, 1 cubed is 1, 215 is a multiple of 5. I'm sure there are many different solutions that you can get for this. It's only 1 mark. So, since 215 is a multiple of 5, statement 1 is not true. Statement 2, when p and q are consecutive even integers, q cubed minus p cubed is a multiple of 8. Part B, prove using algebra that statement 2 is true. So, p is an even integer. Call it 2n, as anything multiplied by 2 is gonna give an even number if it's 2 lots of an integer, and therefore they're consecutive, which means q must then be 2n plus 2, which would be the next even number. Therefore, q cubed minus p cubed is going to be 2n plus 2 cubed minus 2n cubed, which is just going to be 2n plus 2 multiplied by 2n plus 2 multiplied by 2n plus 2 minus 8n cubed. I'll do these two multiplied together first, which is going to be 4n squared plus 2 lots of 2n plus 2 lots of 2n, which is going to be 8n plus 4. Lots of 2n plus 2 minus 8n cubed, which is the same as 8n cubed plus 16n squared plus 8n plus 8n squared plus 16n plus 8 minus 8n cubed. Once I've tidied all this up, the n cubes are going to clear out, so we're going to have 24n squared plus 24n plus 8. You can take 8 out of this. Therefore, it is a multiple of 8, as n is an integer. And we are done. Statement 2 is true.